Hello, welcome to what's part 2 of my SQL class for Alteryx users. What we want to talk about in this video, along with its presentations, is just the very basic SQL SELECT statement. What you need to know to do just a little bit of navigating and exploration in your RDBMS without Alteryx, as well as to lay a foundation for the more complex SQLs that you will want to use in order to do some heavy lifting if you have very large data sets that can't be brought down into Alteryx directly. So let's get started. In this segment, which actually looks short, but I've determined it's not because we have to deal with a lot of nuances of the SQL language and how it might present itself to you, as well as how you might have to use it within your own environment. But we're talking about how to create and execute a simple SQL query, and we'll be using MySQL and MySQL Workbench in order to accomplish this. We'll filter some data, and we'll talk about how you need to simplify your query with aliases, depending upon what it is that you see originally and where you are going. So let's get started by dragging in MySQL Workbench. And we're going to start out with just the very basic SQL statement. All the SQL commands start with a verb. In this case, since we'll be querying data, we start out with the select verb. The next thing you have to do is tell it the object of your verb. In this case, let's just use the number 1. After you have your object, then what you'll be doing is you will be adding clauses to the select statement or any SQL statement, because clauses are how these select statements work. In this case, this is a very basic select statement. We are going to select the number 1. When we execute that, we see down here in our results grid, we get a column called 1 with a value called 1 underneath it as well. Very basic. I like to call this version of the select statement a very expensive calculator, because you can do many different calculations if you want to, such as 7 divided by 21. Execute that, and we get 0.333. So again, very simple. This doesn't really do you much good unless you really just don't have that calculated and want to see what's going on. It actually does pretty good if you're trying out some more sophisticated pieces of attribute processing, such as functions and case statements. But in this class, we're not going to be talking about those, because that is really what you want to do with Alteryx, so you don't have to learn 2 languages. So let's look at a more meaningful select statement. So again, the object of the select are the attributes or columns that you wish to query. We can also use the asterisk or star, as is typically known, in order to represent all of the columns that are in the table that we will be addressing. We identify the table from which we want to get that data by utilizing the from clause. This tells it what tables or views we'll be querying the data out of. In this case, there's a couple ways we can do this. Here in the MySQL Workbench, if I start typing in the name, it will go ahead and show me the options that I have available to me. Here it says that there's a table called puppy table, which is one we want to get to. I can double click on that. It inserts it up in there. That goes ahead and we can execute this, and we can see down here all the records that we queried. You notice that our output is limited in records if we had to, but the puppy table actually only has a limited amount of data in it anyway, as you can see. If we don't like typing or beginning to type, we can also typically, most of the database tools that you'll be using allows drag and drop, so we can actually just drag in the puppy table from over here, drop it there, and then we can also select all the columns from the puppy table. Pretty straightforward, simple to do. So what did we learn very quickly in this? We learned the very basic syntax of the select statement. All the SQL commands have a verb. In this case, it is select. They have some attribute list or an object. In this case, we use the star to get all columns. The select statement is looking for an object of column or attribute in a list. We'll talk about getting more specific here in just a moment. We then want to add in just the very basic clause. The very first one we want to talk about is the from, and you tell it the table or view from which you will be retrieving the data. Keep in mind that the from clause requires an object name. Again, this could be a synonym depending upon your database RDBMS type. It could also be a view or a table. You also might need to reference this object by putting the database name in front of it. So that goes back to how do you name your objects within your database and within your environment. We didn't have to worry about too many of these because we were able to, by default, go into the Daisy Hill database. We'll talk more about how to fully reference these objects, but for now, since these tables are in our default database, we just had to give it the table name. Making it more meaningful, if you don't want to do just simply the select star, what you will be doing is going ahead and we will break this up to make it look a little bit prettier. One of the things I always like to talk about is developing a standard for how you write SQL and then following that standard to make things look consistent, and so someone else can always read your queries. If you have many people working together, it makes sense to get everyone into a room and begin to talk about any kind of structure definitions that you would want to use. But again, if you're just doing it yourself, I still recommend that you create your own standard just so that they look the same to you. I tend to like to separate all of my different tags onto separate lines just so it makes it easier to modify and read. So if we want to select certain attributes, again, we can type them in. Right here we can type in, for example, if we want to see the puppy ID, we can type the puppy ID name. We then want to separate our different objects with a comma. I can also do drag and drop, so I can drag over the puppy name by expanding out my navigator, looking at the columns, and I can drag out puppy name, put it in there. Continuing on, let's add a few more. Let's add breed and kennel. I can actually highlight both of these in my navigator, drag them both over. The tool is smart enough to know to put a comma between them. So now I can list out a specific set of columns that I want to see, and then leaving the from clause the way it was. Execute that. And you see that the output from this is limited to those 4 columns that I requested. Very basic. And pretty much at this point in time, you've learned all that you need to learn about just how to write a query and look at the data that's inside of a table. But there's some other things that we need to talk about in order to allow you to get into more sophisticated queries as well as do some of that heavy lifting. Because what we'll want to do is in heavy lifting is to filter the data. If I have 10 or 20 million records in my table, I don't want to necessarily bring them down into my Alteryx workflow on my laptop. Depending upon the speed of my laptop and the speed of my internet connection, it could take a while. I have found that within Alteryx in my own usage, 2 to 3 million records does not present a problem. So unless I get above 3 million records in order to go into my workflow, I'm really not too concerned about it. Also keep in mind that Alteryx, the expenses in reading the data, once you're processing the data, you're not really going to run into a lot of overhead. You simply have to process the rows one at a time. It is pretty efficient because Alteryx will begin processing your data as soon as the first record is read, so it doesn't need to wait for all the data to come down before you can go. So let's talk a little bit about this where clause in order we want to use it. So we'll come back to our basic query that we've been working on over here. drop it in up here at the top. I'll probably need to make this a little bit smaller because I want to add a few more columns in here just for purposes. We're going to get rid of the puppy ID for further queries, just for clarity, and we're going to want to add in the birth weight and birth date just to get us ready for some more queries. So again, I've got birth weight, birth date, drag those in here. And now what I'll do is I'll add another clause. And it is the where clause. As we talk, this will be for us to be able to separate out our data. So what we want to do here is to choose a Boolean statement. In this case, I want to make sure that the breed name is puppy, so I want to see only the boxers. So I will choose my breed name, drag this in here as well. If my breed name equals boxer. Notice that in my query that my tables and columns are not quoted, and my literal string is in single quotes. So this will return me all of the puppies that are boxers. Again, execute that. You can see that here are just boxers. So that's my basic where clause. And to talk to you briefly about what you can put in that where clause, we'll go back to our presentation. And we have basically 5 operators that you can use. You can use an equal, which is the equal sign, the greater than sign, less than sign. Gets a bit touchy when you get down to combinations. Greater than or equal to, less than or equal to must be the greater than or less than sign first, and then the equal sign. The standard not equal is the less than sign and then the greater than sign. Someone decided that was the best way to do it. Some databases have other alternatives for not equal as well as for some other these, but these are the basic ones and the ones that I always use. So what I can do is I can compare a column to a value, either a numeric or a string. Dates are pretty unique in the fact that you must give it a string, and then that string must be able to be deciphered into a date in the standard date format. In MySQL, the standard date format is year-month-day. Other RDBMSs have different formats. I also can compare columns to other columns. For example, I could compare an emit code to a discharge code if I wanted to do this as well. So what happens, pretty much people say, well, it's never useful to have simply one filter in there. Well, we can use the and or the or to separate our predicates. If we separate them by an and, then both operands must be true. If I separate them by an or, then either one of them must be true. It's also interesting to note that when you begin to deal with these conditions, you got to do a little bit of English to computer translations. So for example, if I want to find all of the boxers that are named Samuel, then I will need to use the and condition. So if the breed name is boxer and the puppy name equals Samuel, I want to see them. So I use the and in there because both of these must be true to return a record. So therefore the breed name is boxer and the puppy name is Samuel. If I execute that, you see that I have one puppy in my database where the breed name is boxer and the puppy name is Samuel. If I want to see boxers and beagles, that's an English way of talking about an or. So if the breed name is boxer or the breed name is equal to beagle, then return me the records. In this case, you'll see all of the boxers and all of the beagles in my output. Now you need to be a little bit careful when you're dealing with complex where clauses, and by that I mean more than two predicates. So for example, if I want to see all of the boxers or beagles that are named Samuel, so if the breed name is boxer or the breed name is beagle and the puppy name equals Samuel, and execute this, and you'll see that even though this reads in English quite properly, from the computer standpoint, it's not very happy about returning this data because we have a lot of puppies that are not named Samuel in this list. The reason why that happens is you have to know what order more than two clauses inside, more than two predicates inside of the where clause are executed. And while it's nice to be able to remember this rule and then process this rule, you must note that the rule says that the ands are executed first before ors, evaluating them from left to right. And what that means, if you look at this query, the first thing that this query will do is it will say if the breed name equals beagle and the puppy name equals Samuel, that'll be the first condition, and then the second condition will be or the breed name equals boxer. So you can see in this list we have all the boxers but only one beagle. Now I could rearrange this query so that it would satisfy those rules, but I don't have to remember how to do that or to test it. Instead, I use parentheses to denote what to do first. It will always execute what's inside of parentheses first before it goes on to the second part. So this basically in this case says to first evaluate breed name equals boxer or breed name equals beagle, and then look for Samuel. So this will indeed return me puppies named Samuel that are either a boxer or a beagle. And sure enough, you can see that I have a boxer named Samuel and a beagle named Samuel. So if you have more than two clauses and you're mixing ands and ors, use parentheses to denote what part of that query needs to execute first. If you're using all ors or all ands, then you don't have that concern. Let's talk about aliases, because now a lot of you will probably first see your query coming from a tool that may have generated it. Tools that generate queries tend to do what I call fully referencing your objects that are associated within your query. And from that I mean we will need to not just simply say puppy table. The full name of the puppy table happens to be Daisy Hill schema.puppy table. So if I drag Daisy Hill down here because I don't want to type it, that is the name of my schema, and that is the puppy, where the puppy table resides. And just to make this easy, down here we will go ahead and simplify this just to simply be the puppy name. When we execute this, you'll see it will still work properly. And it turns out that we only have two puppies named Samuel, the boxer and the beagle. But continuing onwards with the full name of it, this column is not just simply called puppy name. It has the full name of daisyhill.puppytable.puppy name, or periods if you choose. So the full name of that column happens to be the schema name, the table name, and then the column name itself. So if I was to write this as a fully referenced query, I would need to put all of this in front of it And if you've ever looked at the queries that come out of some of the query generation tools, this is indeed what they do. So it is nice to be able to see what these look like. Now, when you begin to do a join query and have two tables in the same query, you do need to go ahead and denote. Notice that this sort of got left out over here. You do need to, we also need to execute it, going backwards. So there we go. See, it still works the same. However, like we were saying, so when you have multiple tables in here, you need to identify which columns are coming from which table. And while you can do it in this manner, it gets to be very, very verbose. This is where the idea of aliases come in. And so what I would want to do is to define an alias for this table in this query. And you typically say as PT. So now anywhere that I wish to use this schema and table name, I can now just simply use PT. So this can right here can become PT. So now this lets the query optimizer know that each of these columns are coming from the table that's referenced as PT, and then PT means Daisy Hill puppy table. We can now execute this, and it returns the same results. If you don't like puppy name coming out there as the column, you just simply want this to say puppy, you can also rename or give an alias to the column that's being returned. So I can put as puppy. For example, here, I can execute this, and now you can see the column, rather than being puppy name, is actually saying puppy. That's for a way for you to rename the columns that are coming back into your result set. If you have seen queries along these lines, you might not have seen the word as. This word as is optional. I tend to like to put it in there for my attribute names, just to make sure that my syntax is correct, and I typically almost never use it when I'm giving an alias for my table names. So the as is optional. You do not have to include it. So you can see that this executing returns the same answers because we just simply simplified what we were typing in. So that takes a very quick overview look at creating a select statement where I select column names from a table and a where clause. I can also use the navigator to help me fill in the names of columns and the names of the tables to help me with generating the query. In the next sessions, we'll look at how to make these more complex by joining multiple tables together and talk about different join types and the syntax for joining them. Please subscribe to my channel. If you have any questions, drop me a comment. I'll be more than happy to answer them and share future videos with you as well. Have a great day.